Today, before we get started with our stream, I just wanted to show you something new that we have in stock that's likely going to cause Paul S. to quit his job. This here is a nozzle that will allow us to work on touch bar CPUs. So all those touch bars with no image that we think may be because of the CPU, now we can start taking CPUs off donor boards if we ever find some with donor that are good, and we can use this nozzle with this machine back here to replace CPUs. And this is going to be exclusively the job of Paul S. Okay, I'm going to open this MacBook. Alright, today we have an A1278. This machine has the microphone tucked under the board. Great job, dumbass. Really? You're a store. What the fuck are you doing, man? Why would somebody do this? It's a little MacBook. Look at this. Why the fuck is the microphone not where it's supposed to be? So this microphone, see this that I just pushed out from under the board? That's supposed to be in a little slot over here where the little holes are so that the audio comes through. It's not supposed to be shoved under the board. Green light. Fan chooch? The fan does not chooch. Fan is not spinning. So we have to figure out why the fan is not spinning. So I'm going to take the Mac out of the book. Just like Tim Cook, it only has one fan. You know what's been killing me about Tim Cook recently is I've been reading more and more of these articles saying, why is Tim Cook worth less money than CEOs of companies that are worth less than Apple? And then I think that he's trying to revitalize his image and have this idea that he doesn't care about money, which the fuck he doesn't. Oh, you don't care about money? That's great. So why is it that I can't use screens that I bought to repair your products? Why is it that you made it so that the old EDID codes won't work on the newer operating systems so that I'm forced to buy display assemblies rather than LCDs by themselves? Why do you solder the SSD to the board? Why do you sell an $80 dongle for USB-C and make it so that that's the only dongle that works with your MacBook? Why don't you admit until the last minute that there are problems and faults with your products? Why don't you have an extended warranty program for the iPhone 6 Plus, which you know has issues, but rather charge $149 for repair? You don't care about money. Really? Really, asshole. Like, that's the thing. You could tell which journalists are the ones that are completely full of shit versus the ones that actually do reporting by just reading this crap. Because I know that Mark Zuckerberg tried to do the same thing last year. Mark Zuckerberg went on this tour to try to rehabilitate his reputation so that people wouldn't hate him for being a billionaire and wanting to spy on people and all that. Like, he was really trying to undo this, why do they trust me? Oh, stupid fucks. Like that thing that he did in 2004. And I don't think people fell for it. But I think people have fallen for the Tim Cook one. You don't care about money. Oh yeah, Tim Cook does it for the passion, for the love. Fuck out of here. No, he does not. No, he fucking does not. You won't let your own goddamn authorized service centers replace batteries to a 2013 MacBook Air. No, you don't do it for the passion. No, you don't. No. All right, this is an 820-3115 motherboard for a MacBook. This is a fan that's not chooching. So we need to figure out why this fan doesn't chooch. Let's open up a schematic for an 820-3115 MacBook and put it on the screen. The first thing that we're going to need is to check our power rails. Our power rails are going to be on page 7 of the diagram. We're going to start at the top with PP bus G3 hot. As you can see over here, PP bus G3 hot is supposed to be 12.8 volts. It's actually supposed to be 12.56 volts, but we can't expect them to get it right on their own schematic now, can we? So let's put the multimeter on the screen. and we're going to measure at some of these rails and see what's present and what's not present. Our PP bus is going to be over here. And PP bus is 12.56 volts. So now we move on to the next rail. PP bus S5HS computing iSense. We can find that on the other side of the board, right over here on one of these capacitors. And there we get 12.5. Now we can check this one over here. And we're going to get this on one of these bottom capacitors. And we have 12.56. So we continue. Now the DC in rail has to be there because everything else is there. And PP3V42 is there because we're getting a green light. Let's continue down to PPVRTC underscore G3 hot. And see what we're getting at PPVRTC underscore G3 hot. At PPVRTC underscore G3 hot, it looks like we're getting 3.3 volts. So that's good. Next up, we're going to go for PP5ES5, which is supposed to be 5 volts when the computer's in an S5 state. So let's check out our PP5ES5 and see what we got going on there. PP5ES5 is 0. That can't be right. No, it's 5. Is it 5? 4.97. Now we're going to go to the next one. So now we're going to check out PP5ES5 sus. Let's see if that's present on my board. Where's my PP5ES5 sus? PP5ES5 sus, 4.97 volts. All right, let's see if PP5ES3 is present on this fat book. PP5ES3 can be found over there. Come on, little fat book, you can do it. Give me some PP5ES3, and it's not there. And if we were to chase that all the way back, you'd see that that's because PM Sleep SRL is probably missing. Now, PP5ES3 is going to be created by our TPS51125 down here. TPS51125 is responsible for the 3.3 volt S5 and 5 volt S3 power supply. And its enable is going to be this N-trip pin over here. This N-trip pin cannot be brought to ground. This transistor over here is going to bring the N-trip to ground, therefore not allowing it to be tripped. Now this transistor is an N-channel transistor, so it's going to work when the voltage in the gate is higher than the source. So we got to get rid of this signal. That's why this thing has to be underscore L, which is low. So let's find out where this signal comes from on the schematic and the board view. That's going to come from PM Sleep S4L. So do you think PM Sleep S4L is going to be present on my board? Do I have PM Sleep S4L on my board? PM Sleep S4L is missing. Boo. All right, so let's take a look through my board under the microscope and see where that is. Hopefully we can find out what is causing this problem by searching for something that's obviously damaged. Microscope time. What is wrong with this MacBook? Let's see, do we have anything by the RTC area? That's great. Aha! Hint. 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 Ooh, right, our RTC area, we have nastiness. Look at that. Okay. Here we go. We're finding something. I found a hole. Down in a hole. I want to fly, but my wings have been so denied. So that is PPVRTC underscore G3 hot. And that is going to be pulling up several signals. RTC reset L and system RTC reset L. If those signals are not pulled up, if the RTC circuit is not working the way that it's supposed to be working, then this board is not going to chooch. You need RTC reset, system RTC reset, intruder, and int vermin. So RTC reset, L, is going to cause a system clock reset when it's low. This is going to cause a system clock reset when it's low. This is going to tell the system, oh my God, there's a burglar. There's a burglar. Call the police. There's an intruder. And down here you have intervermin, which is going to tell the computer, oh my God, look, there's vermin, there's a mouse in here. So _L means when the signal is low, it's asserted. So you don't want it to reset. You don't want the system to think there's an intruder. And you definitely don't want the system to think that there's a mouse. MacBooks do not like vermin. So what we need to do, besides firing Paul Daniels for the fact that my PDF reader just crashed for no good reason, what we need to do is see if those signals are being pulled up. Now, they are pulled up by PPVRTC G3 hot. However, is that going to be there at these resistors when the place where RTC reset, where the PPVRTC goes from the other side of the board to this board is totally burned out? Look, see? Watch this. You look right over here. This is all these resistors on this line. All that stuff, that capacitor, that resistor, comes from here. And as you can see, blown. That is blown. And remember, if you look on the schematic, the RTC voltage is created by U2600 over here. U2600 creates PPVRTC _G3 hot. That creates this voltage, PPVRTC G3 hot out. So the voltage has to be able to make it from this side of the board over here to this side of the board over here. And it's going to do that through this little hole. And this little hole is messed up. So we need to run a wire and fix that. And thank you very much. I think that's really cool that you started doing board repair. I hope you don't have 15-inch 2011 unibodies. Hopefully, for your sake, those are 13-inch, because the 15-inch all have GPU issues, and those are going to suck. So what I'm going to try doing here is I'm going to run a wire through that little hole in the board. Let's see if it'll actually fit. This is going to be fun. Start watching YouTube videos. Love them. Really entertaining, even though I'm more in engineering. Not into engineering. Cool. All right, so I'm going to run this wire through the board, and I'm going to use my new set of tweezers that I'm not letting anybody here touch, especially me. I'm going to run this wire into the board. Let's see if I can make it through. Will you go to the other side? Oh, it will. Go, go. Okay, I want to see that wire on the other end. Woohoo! All right, check it out. You got a tunnel wire. So it's coming out the other end, and if we look on the schematic, you'll see that right where my wire is coming out here on the other end, it's going to PPVRTC G3 hot. So if I'm getting PPVRTC G3 hot over here, what I'm hoping is that I will get it on the other side if I solder there. But I'm also not sure if I'm even getting it over here. So I'm gonna be very safe with this, and I'm actually gonna run my wire all over the board. So check this out. Check out what I'm gonna do. I'm gonna run this wire all the way up here, all the way up to where PPVRTC G3 hot is supposed to be coming out, right up to this capacitor over there. And then I'm going to run it all around the board. And after I run this little wire all the way around the board, this MacBook is going to chooch like a MacBook again. You're using it wrong. You're MacBooking it wrong. All right. Good stuff. Now to the other side of the board. And there's my wire. Now we're going to hook up my wire to where it's supposed to go. Do all of you remember where that's supposed to go? I hope you do. It's going to be going to this capacitor and these three resistors. First, we're just going to add a little bit of flux. Small amount there. Loving you is easy 'cause you're beautiful. So now we're going to scrape away at this. Do I even really need to scrape away at that? I'll just wire it directly to the capacitor. What am I thinking? So where's my wire? Wire, wire, jumper, fire. How do I have mini Ripperton stuck in my head? All right, so that's soldered. Now that's a sick looking wire. It starts at the RTC voltage creation chip. Let me just break off the excess. So it starts here, runs around the board here. You might be able to make that a little neater by doing this. All right, that's neat. So let's go through that again. The wire starts up here by the RTC chip. Then it makes go down, it makes a left, then it makes a right, and it gets soldered to the RTC via, where it then pops out on the other side, over here, and then goes to that capacitor, that resistor, and that resistor. And after that, because I want to get a fan spin, Daniel, I invested in AGRX. I can't afford a single missed board. I invested in Agile Therapeutics. I can't afford a single board to not be repaired. Fan spin!
You should not be hitting
Ow!
No.
I can hit the table as much as I want. I will hold the board by the wire. How about that?
No!
I'm going to pick the board up by the wire, Daniel. Do you think I can do it?
No!
Why not?
Don't do
I'm going to pick up the board by the wire, Daniel, while it's on. I'm going to pick it up by the wire.
Don't!
Don't?
No!
Okay, fine. My assistant is literally screaming at me that I'm not allowed to pick up the board by the wire. Look at that fan spin. That was more art than engineering. Yeah. That wire is so thin, it actually fits through the holes in the board. So that's a fix. That's awesome.
That's a main channel video.
That's a main channel video.